Hey, good afternoon. How's everybody? How are you, Maricel?
Hi, Professor.
How are you, Jimena?
I'm
Hey,
good.
good
How are
afternoon,
you?
Professor.
I'm good. How are you, Mohammed? All right. Again, Maricel, do you have a question or because you're just saying hello, but your hand was raised. So, all right. We have just three people just so far. Um, and just like yesterday, uh, just uh, I guess the rest of the class is still signing into the forum. I see in the forum, in today's forum, we have five people in today's forum, so at least two more. There's Lana, there's John, and these people should be joining us very shortly. Um, so let me share my screen. Okay, I just want to make sure. Okay, we were. Okay, so we need a little review of the we need a little review of the properties of exponent because yesterday um, we basically finished the class with uh, the formula for finding rate, right? And the rate to understand how, the steps of derivation, right? How the formula is derived. To understand that, um, you first need to understand the properties of exponent, the properties of power, right? Power functions. Now let's see. Still, what's going on? I have only three people, and in the forum, just five people. What's going on? They just log in and don't come to the. That's fine. I mean, as long as they are keeping up with the. As long as they are keeping up with the topics, right? So we are actually. You don't see. They already. They already passed, right? They already uh, more than 5 days old, so you can't see them. But you should have watched all of these. There are still a couple of videos, lingering from the last topic because they haven't been there for 5 days yet. Uh, and the session recordings are visible until the end of the weekend. So Sunday is the last day. Uh, so this one, this is yesterday's recording. This one will be there until this Sunday, but the ones before that were already done because they were, from uh, the Sunday of the week of that week was right August 1st. So they were available until August 1st, but no longer. But again, they are available. on YouTube, right? I believe this is Mohammed, right? The I have everything from day one to up to yesterday, and it will be also today's session recording will be also updated there, right? So um, uh, okay, so what I wanted to say was basically you gotta be all caught up. You gotta catch up with, we are currently, you see, the discussion we are having in Collaborate is not where we are. Where we are is here, right? As of today, these new videos opened up, and I wonder why. It opened up on August, last available on August 2nd. Why? These things are still available. Mm, Okay, so today, topic 3, financial statements intro, part 6, and then financial statements part 1 and 2. So actually, this one should be available. Let me intro 6, and it was available July 28th. No, I think it should be available from today. Oh, this one wasn't even. Yes, why? August 3rd. 5 days will be August 8th. That should be okay. And that should be like exactly like, yeah. Okay. So you should be caught off all the way to these videos. It doesn't really wait for you. Okay, you gotta catch up. Um, and let's see. Yesterday, let's see, August 2nd, right? Financial statements intro, part 1 through 5. Yeah, that was yesterday. So these are, see, I want, and we have 7 people. So I want to drive this home. I want to drive this point home to everyone. How come, only 3 people? I mean, there are 7 people in the discussion board and only 3 people. And I want to emphasize this, right? This is our class. This is our lecture as of today. You understand? We're not. Um, what is being discussed in the collaborate session is not our, that's not our lecture for today. Our lecture for today is actually Financial Statements Intro 6, and Financial Statements Part 1, Part 2. Okay? And yesterday's lecture was, Intro 1, 2 through 5. Okay? And everything we are, as I said, we are just reviewing. In the collaborate session, we're just reviewing and reflecting on the past lectures. And actually, the purpose of the collaborate session was to take questions. If you study, right, according to this schedule, then some people will have questions. And for those people, I'm giving, I'm this chance to ask questions through the collaborate session, right? This is not the class. This is not the core of the class. You understand? If you think, you don't have to watch those, assigned videos for each day, then you are wrong. You are grossly, because in the collaborate session, I cannot move at the speed that should be, I cannot move at the speed that was, supposed to be, that I was supposed to be moving at, because in collaborate session, unlike the ideal expectation, a lot of you can't even barely follow what I'm talking about. Cannot even, understand, comprehend anything. Some people cannot even, and then just to spoon feed everyone. Spoon feeding, you cannot expect to be spoon fed in college, right? You must study on your own. I mean, it's not exactly on your own. You are learning from my lecture video. You should study. What I'm saying is study in your own time until you completely digest the material. But then, without making any such an effort, a lot of you, at least some of you, just expect to be spoon-fed and cannot be spoon-fed. If I'm a brain surgeon and if I can open up your cranium and put these ability, these power into your brain, that would be easier. But I cannot, open up your cranium, by words, no matter how, how loud I shout. It cannot be done. It has to be coming from within you, right? So again, collaborate is not the class. I repeat over and over, collaborate is not the class. It's just the review and reflection. The lecture, the class is actually up here today. This is, your class content, class material today, right? And this was your yesterday's class material, right? So please catch up with, the lecture content up to today. Don't rely on, because sometimes, if I'm, think about it, I don't have, my lecture doesn't have to be, missed. I mean, if it is, a physical class like, before pandemic, right? If I cannot make it to school, if I cannot make it to class one day, whatever, health for health reasons or for traffic. There's some for traffic issues, whatever. You will be missing the class completely, because if I miss 1 hour, if I'm even late by 1 hour, right, the class will be, if it is just 1 hour class, there will be no one. And the students think, they are getting a break by, if I don't show up for the first 15 minutes, some students cannot even wait for the first 15 minutes. They think um, uh, they are taking a well-deserved break, not thinking that they are losing the time and the um, the lecture that they were supposed to get, right? That's usually, and they don't even, and they have nothing better to do, but they just leave the classroom after the first 15 minutes. But what if it was, suppose if it is, 1 hour class, right? If I'm not there in the first 15 minutes, um, it is actually, not, it is uh, legitimate, right? I mean, uh, it's legitimate to leave the class, because you missed, the first 15 minutes, but then 15 to 20 minutes. But unless you have nothing better to do, staying in on is to your best interest, because I may arrive, I may be held up in traffic, but arrive like 16 minutes past the hour, right? 16, so like 11:16 I arrive. And then I still have like, 35 minutes of class, 34 minutes of class. I can conduct class. And for those who have left, it's their fault, it's to their loss, because the other classmates who remained in the classroom will get 35 minutes of lecture, while that is completely lost or foregone to them, to a couple of people that have left, right? And you cannot recover it if you um, miss the class. You cannot recover it. And what if it's a 2 hour class? You can't leave after 15 minutes, because out of 2 hours, 15 minutes is only, like uh, 1/8, right? 1 hour class is 1/4, 15 minutes is 1/4, but 2 hour class, it's 1/8. Just because, the professor is late by 15 minutes, 1/8 of the class, you just, trash. You're just throwing away, uh, 7/8 of the class, right? And they think it is their right and God-given right, and as if it is um, by coming to class, they think as if it is their they are doing a favor. Favor to whom? Huh? You're not doing a favor to the professor, by coming to class. You're doing yourselves a favor. And if you miss the class, then you're doing yourself a disservice. Isn't it right? After having paid the tuition, right? If you miss the class, then you are doing yourself a disservice, right? But again, in a physical class, that can happen. I mean, I may be, for health reasons, I may have to, um, cancel the class um, for a certain date, and there is no time to make that up, because what other time can there be? If I miss 1 hour, it has to be made up by another 1 hour. But then students all have different schedule, right? It's not like I can make it up. I have to create physically another 1 hour. Will that have to be after the semester is over? Huh? I mean, if the semester is over on, if it is spring semester, May something. I mean, the last day of class is May, let's say May 15th. And then after that, it's reading day. The only time I can use is the reading day, one reading day, and after that, final. You cannot have any more class after the final. What's the point, right? So the only day possible is during the reading day. Sometimes, they don't even give reading day. Usually there is one reading day before the final, right? But that one reading day, sometimes you don't have in the college calendar, it's not built in some years or some semesters, right? But usually there is. So that will have to be, if I had to miss like, 1 week, that's 3 hours. Still, it can be made, but depending on the student's, situation and schedule, it may never be done, right? And it cannot be made up on any random day because students cannot make it because they have other classes or something, right? So that is totally, there's a lot of constraints and limitations in a physical class, but in an online class like this, even if I'm, let's say I have to take a day off because, my health isn't, that good, but still you don't miss a day because my pre-recorded lecture is there, right? You're not missing a day. And as I said, this collaborate session is only a supplemental thing, right? This is not the main lecture, right? If this is the main lecture, it's still the same thing. If I have to take a day off, it's completely, missed, right? And it may not be there may not be any convenient day to make it up, right? So please don't think this is the class. Don't think the collaborate session is the class. Collaborate session is only an auxiliary supplemental function. Okay, everyone understands that? And please understand that the class is here as of today. Okay, so you must be all caught up to this point, up to this video. Okay? So everything I'm doing now is just a review and reflection of the previous classes. So let me go back. Okay. So now let's think about it. The reason we did this is because of, 4 variables. Why? The formula consists of 4 variables. Future value is, that's the unknown here, right? You don't know the future value, but you know the principal. You know the interest rate. You know how many periods you are putting the money in the bank or in any investment instrument, right? So then, if this is the unknown, this is what you do. But if the principal is the unknown, that's what you do. If the principal is the unknown, that's what you do. And again, if the interest rate is the unknown, that's what you do. In other words, what do you see here? Everything is basically a tweaking of all these formulas are basically tweaking of the initial compounding formula. Isn't that right? You're solving you're solving this equation, right? The base equation for PV, and then the formula is, then you're solving for that, and that's discounting. And that's present value equals 1 plus r to the n, right? Okay. In other words, when the present value or principal is the unknown, right? And then if interest rate is the unknown, you solve this equation for interest rate. So it's basically a question of what is the unknown, right? If the interest rate is the unknown, you solve for the r, and then this is, took a lot of time just to derive this formula. And then next question is, oh, what if n is the unknown? How do you solve for n, right? Isn't that right? Isn't that the legitimate, isn't that the legitimate concern? Isn't that the legitimate question, right? How many years will it take, or how many quarters will it take? How many months will it take? And to answer that question, right? So here, let's go back to the previous example, right? And also we assume let's not, let's just assume that it is, again. Oh, I didn't have to. I already had it here. Okay, this time, look at this row 26, and what is it about? You have $10,000 today, and currently the interest rate is 24.57, and currently compounding is just once a year. So to grow this 10K to 30K, right, given 24.57% interest rate, with just annual compounding, how many years will it take, right? This is a very plausible question. You understand? It's a plausible question. Then how do we solve for that? How do we solve it? We know the answer already. I mean, because it's the same scenario, right? We'll have to take 5 years. But if this is the unknown, right? How many years? We don't know that. Previously, we didn't know APR, but we solved for it. But if APR is known, principal is known, future value is known, this target future value. I mean, this is what you desire, right? This is the target future value. And then, how many years will it take? That's a legitimate question. But to answer this question, then, it's going to be a very complex to understand, right? The theory behind it. The formula is this. That's already, you, Professor, what is that? What is that? Is it 1n or ln? Explaining this is what's going to take another hour, maybe 2 hours. But that's why I gave you should have already watched these videos already, right? This is topic 3, but it was already in topic 2. What's happening? Do you know what SCF stands for? Hmm? You must have watched all these videos, and if you don't know what that stands for, um, then it's too bad. That's to your own detriment, right? You don't know what that is. That's your own disaster, your own misery, right? Your own that stands for single cash flow model, because there's single cash flow model and multiple cash flow model. You have so far what we have been doing is only single cash flow model. And then if there's a single cash flow model, there's multiple cash flow model, right? And between single cash flow model and multiple cash flow model, uh, there were videos about Euler's number and natural log. LN stands for natural log, and you should know that. If you say, Professor, I don't know, look, your fault, right? Your fault, because these videos were provided there, and while they were there, you should have watched them. And why, as you watch them, you could, because they were available for 5 days, you could play at least, even if you watch once a day, you could have watched 5 times. And while you are watching them, if you don't understand anything, you can pause the video and come to the collaborate session and ask. Nobody asked anything about Euler's number. Also, it is well explained in these videos, but if you still have hard time understanding it, then that's something you have to digest, right? As I said, I cannot open up your brain and put it in there. It's something you have to research and study until you can digest it. And still, and I've noticed some people have really no more than 8th grade math level. And for those who, it may take more time. It may take more time, but it's not undoable. It's not undoable. And I was surprised, some people don't understand what exponent means. What power, something raised to power. Ten cubed, right? Again, 10 cubed, or 10 to the 3rd power, is not 10 times 3. It's 10 times 10 times 10. That's power, right? And 100 to the 3rd power, 100 cubed, is not 100 times 3. And I was just surprised that some people were doing that. I was just shocked. 100 to the 3rd power is 100 times 100 times 100. How can that be 3 times 100? That's 100 times 100 times 100. That's 1 million. And also, which is the same thing as 10 to the 6th. 10 to the 6th power, right? 10 raised to the 6th power. Because, so anyway, so if you didn't watch these videos, but I've been telling you, you can find them. I gave you my YouTube channel playlist name. You can go to YouTube channel and find it. And although this class is business to 10, right? Some of the videos you must look it up in business FNB 100, because these videos are cross-listed. I don't need to, common videos, common lectures, they are cross-listed. Some of the videos, students in my Finance 100 class also need to go, look up the videos in Business 210 because they are cross-listed and they are, so for Euler's, number, you go to my, FMB 100 playlist, and then it's all there. Single cash flow model 1, 2, 3, 4, Euler's number for n, right? Part 1, part 2, future value of annuity. These are all multiple cash flow models, okay? But you don't, that's it. You don't have, nothing more, right? Nothing more than that. Oh, as for financial statement, I gotta also think about it. You don't have financial statements there. Financial statements are actually in Finance 230. Yeah, all those, financial statement intro. If you, if they are gone, then if they are no longer on Blackboard, then you must go to the YouTube. You must go to YouTube and look it up. It's all, here. So anyway, okay. So let's so it takes a lot of time. Actually, steps of derivation is like this, but then you have to already know what natural log is. So to understand that, but it takes it's taking it will be taking almost the entire 2 hours. It's been already 40 minutes already since we started this class. So, without further ado, let's go back to the properties of exponents again. So yesterday we were talking about some of the properties of exponent, and there was something we didn't talk about. Generally, and this is I want to talk about this because it's an interesting thing. Let's see if there's a space there. I want to, or space down here. Okay, does everyone understand? We all know, I believe, at least you would know by now, x raised to 1 is just itself, x, right? You all understand that. And reciprocal, negative power, x raised to -1, you all know it is 1 over x, right? So then x squared is x squared, of course. X to the -2, x raised to -2. I wish I had something better than this. X raised to -2 must be what? The negative power is the reciprocal. Does everyone understand that? Right? Because I don't want to repeat this over and over. I'm just killing myself because I'm exploding, actually. You don't see me, but inside, I'm exploding. people explode when um, if you're speaking to if you're speaking to the wall, right? Or if you're shouting into a echo chamber. At least in echo chamber, there's echo. But if you're speaking to a hollow vacuum, there's nobody, no intelligence, no intelligence, nothing there. You're shouting, you're shouting to the wall. What do you get? It because because of that, total lack of uh, any response or any sign of intelligence out there, right? Then you get frustrated. Not just it's not because when someone doesn't understand, you get frustrated. No matter how you try to talk sense into them, if they don't understand, if they are just like a mannequin, you know the mannequin, the dummy, right? You speak to the, they don't respond, right? You try to explain something to, you just get frustrated, and then you explode. I mean, people explode, of course. Inside I explode. Then um, that that uh, that does harm. That only does harm to me because to my health because that raises my blood pressure, right? I'm already, um, I'm already hypertensive, Uh, I'm taking blood pressure medication, because I have, slightly am hypertensive. It uh, it impacts your heart. Uh, but it's only doing damage to me, right? Not to the other party, right? It's like you just they don't care. They don't know. I mean, you're trying to speak to the mannequin. The mannequins don't care. They don't even know that they are being um, whatever is happening there. It's like like a dead log, dead wood, the timber, lumber. Speak to the lumber. Lumber doesn't. You get angry, you get frustrated and angry and explode at lumber. Lumber doesn't know, right? It only uh, it's the one who is exploding. So, but since I cannot see your response or reaction, uh, I don't know if you understand this. But yesterday, some people understood, some people didn't. Still, didn't. And even today, if I ask again, some people still don't know. That's the problem. You're not in elementary school. You're not in middle school. As someone with with an intelligence of 20 something, or at least someone, uh, if you're 21, that's legally, you can drink legally, right? You can consume alcoholic beverage, and you want to be treated like an adult with adult mature, of course, intellect isn't mature when you are 20 something. And I would say my intellect was at its highest, I mean, at its most mature, or maybe most efficient level when I was in my late 40s. Of course, that doesn't mean I got dumber than when I was in my late 40s, but people get smarter, not only with it's with age, but not only with that, with training, right? Intellectual training, which is what basically studying. Studying is an intellectual training, right? Intellectual is not someone who reads novels. I've been telling you over and over, right? Liberal arts have very little to do with really, intellectual. I'm not saying, great novelists were not intellectuals. People like Tolstoy, the great writers, were really intellectuals. But to write such a great novel, you have to be, you have to have this uh, ra- uh, analytical thinking ability, logical thinking ability, analytical thinking, logical thinking or reasoning, critical thinking. Uh, these abilities are fostered or trained through, education, training. In other words, they are trained, something that can be developed through training, and you gotta, um, and those abilities are not developed through something like just reading a novel or reading an essay or anything like that. It takes uh, it takes brain training. And what is drill? What is a training? It's like, um, if you want to get better at martial art, you have to actually practice every day, but also you have to actually have a battle, mock battle, and it's not a pleasant thing. You get hit, you get beaten sometimes, you get kicked, you get you you get hit in the stomach, or you get hit in the head, right? But through that, like boxing, you have to train, and then you get beaten, in a boxing training, of course, and then you realize what is your weakness, and you try to beef up your weakness, right? Because it's never a soft, mushy, pep talk, or you'll have to be beaten. You'll have to be beaten up to know what your weakness is and where you need to uh, beef up. You understand? And then by doing that, you get better, because the boxers, they will dodge. They will know, they will learn how to dodge the the other guy's fist, right? In martial art training, you gotta, you will learn, because you will learn to dodge the and guard against the opponent's kick and punch, right? Only by getting hit by them, getting kicked and getting punched by them first, because then you will be watching where the kick is coming from. You'll be watching where the punch is coming from, and you'll either dodge it or put a guard, raise your guard against it, right? But that's training. Training is not a pleasant thing. Training is not definitely not a pleasant thing, because sometimes the training uh, makes you realize uh, how little you know, or that you know nothing, or your intellectual ability capability is very low. But then that's the starting point. If you realize that, then you gotta develop it by training, right? So anyway, so we all know, we all understand, okay? Uh, x raised to n is, of course, x raised to n. That's x times x times x times x times x times, n times x raised to n. This is the general notation. X raised to negative n is, of course, it's the reciprocal, right? 1 over, come on, 1 over x to the n. And then we also know that x raised to 1 over n is nth radical of x, right? And also we know x to the a raised to b is x to raised to a times b, right? Just not, we did all this yesterday, so it shouldn't be that difficult, right? Shouldn't by now. So that's why we could do this, right? That's why we could, x raised to n that's why we could do this. Raised to 1 over n, then we could get rid of, then that's x to the x to the n times 1 over n, where these two cancel out. Therefore, it becomes this x to the 1, which is, x. Okay? Now, next question, then what is x raised to 0? What's x raised to 0? Anybody? Now, since yesterday, people missed the chance to earn extra points. If you don't want to earn extra point, that's fine. What is x raised to 0? What is x raised to 0? Anybody? No one?
Is it 1?
Yes, it's 1. And who was that?
Hannah?
Who said that? Hannah. Yeah. Thank you, Hannah. So you got extra points. 0.25. Business 210. Today is August 3rd. Okay. Yeah, but how do you know it is 1? Of course, most of you just memorized, from, our middle school, I remember, I memorized it in middle school, because they told you to just memorize it. But actually, later, when I was in graduate school, because as an undergrad, I didn't do economics, or I didn't do anything related, that has to do with, math. So during the undergraduate days, I didn't even bother to, But later, when I went to graduate school and, studied economics, always why came up. How and why? How? First of all, how? So I studied. In other words, I did my own research. I looked up here, I looked up there, and I looked up, every, related. And then, of course, I looked up, the rule of the exponents. Like, I looked up these, and then I figured out. For example, so what if we have x squared times x to the negative 2. x squared times x to the negative 2. We know that it's x squared. It's very simple. Times 1 over x squared. Isn't that right? Isn't that right? X squared times x to the negative 2, right? That's x squared times 1 over x squared. Isn't that right?
Yeah.
Yeah.
Okay, yes, thank you. Who said that? Hannah?
Yeah.
Who said yes? Yeah, thank you, Hannah. Just you don't earn extra credit, but thank you for responding because, as I said, since there's no reaction, no response, I don't know if people are in here. They may have just logged in and just have disappeared. You could have may have logged in and just doing something else actually, right? And I hate to be like talking to the vacuum, right? So what is this? They cancel out. They cancel out. So it's 1. But then what? What does it have to do with 0? Now think about it. What is this? This this is again. This is a because they have the same base. It's the same thing as, remember the rule of multiplication, the product rule, uh, same base, right? A raised to B times A raised to C, because it's the same base, right? You simply add them up, right? Because think about it. Um, uh, so this is going to be 2 plus minus 2, right? Oh, give me a break. Okay. Right? Then what is that? X2 0, right? So that's why it is 1, right? Does everyone understand that? Does everyone understand that?
Yes.
Right?
Yeah.
Yeah. All right. Thank you. All right. That's why. Now, next thing. Then what is before talking about Euler's number? Then uh, what is log or logarithm? Okay, here so logarithm is basically expressing a number by its exponent. Okay, logarithm is a way of expressing usually a large number by its exponent, because a large number is very onerous, it's burdensome to express. In other words, let's think about, so I'm going to be, instead of going down, let me come up here. Bring it up here. Okay. And okay. So we all know what 10 to the 6th is, right? What 10 to the 6th? That's, of course, 1 million, right? I don't have to rewrite this. You gotta have put 6 zeros, right? That's 1 million, right? So this is, in this case, let's call this A. Let's call this A. Let's call this X. Let's call this B. Let's call this X. Let's call the exponent X. Let's call 10 B. B stands for base, right? Okay. Now, so that looks, pretty much like B to the Y. Okay, that's fine. And so then we can also write this as we can also 1 million can be expressed as log of base 10 log, right? Base 10 log of 10 to the 6th, or base 10 log of 1 million is 6. Yeah, 6. Base 10 log of 1 million is 6. Okay. Why? 1 million is taking the log means we are using some base number, and the base of the log is, there are 3 largely used base. Largely used base: 10, 2, and E, Euler's number. Okay, E stands for Euler's number, or exponential function. So other numbers can be the base, but they are not commonly used. Okay, and it's not easy to visualize what that number might be. I mean, think about it. Any number can be logged, right? Like 13.75, right? Can be. It's hard. It's not easy to just mentally calculate it or visualize it. But base 10 log of 13.75 is possible. But human brain cannot easily calculate it. But that's what the computer is for. We can have the computer calculators. But then just for our thought experiment, it's easy to work with, the powers of 10, like 1,100, 1 million, 1 billion, 1 trillion, powers of 10. We can work with powers of 10. It's easy. And if the base, especially using 10 as the base. We know, actually, I should have started out with this. If you take base 10 log of 1 million, right, you can write it like this. And if you write it like that, then the log has a property of the exponent, any exponent the exponent can be brought down like as if they are coefficient. Understand? Exponent can be brought down like coefficient. First of all, then this will turn into simply 6, because what is the meaning of base 10 log of 10? What is the meaning of base 10 log of 10? What do you think is the base 10 log of 10? Of course, it is 1. Think about it. Base 10 log of 10 is nothing but saying 10 raised to 1, right? And if you take the log of that, right, through the same process, it will simply be just 1. And that's why I said earlier, right? That's what I said. That's why I said log is a way of expressing a large number by its exponent. Log is a way of expressing a large number by its exponent. Okay? Everyone is clear about that? So why is it necessary? I mean, why do we need to think about it? One, suppose you are, launching a rocket to, go to another, galaxy. I mean, of course, going to Mars takes, 3 years or something. I mean, the speed of, just reaching Mars would, and the distance between, Earth and the Sun, using that as the basic unit, I mean, we can express, how far the distance is between the Earth and the nearest galaxy. But then think about it, that would be like billions and trillions of miles, right? How would you express trillions of miles on a map or on a diagram? For example, you draw, this is the distance, right? And let's say basically this is the distance between the Sun and the Earth, right? And let's say distance between the Sun and the Earth is, let's just to make it, just 10 miles. Of course, it's not 10 miles, but some, let's say 10 something, right? And the distance between the Earth and the nearest galaxy is, let's say, 10 trillion, 1 trillion miles. 1 trillion miles. Then, how would you put it on a paper or, on a whiteboard? I mean, putting it on a paper, right? It is certainly constrained. I mean, on a computer screen, yeah, I can extend it like infinitely. I can extend it, as long as a computer can generate more space, right? I don't know how many of you have watched the movie. I forgot the name of the movie, but it's not Wayne's World, but uh, it's Jim Carrey movie. A Truman Show. Truman Show. Did anybody? uh, Is there anyone who did everyone watch that movie, or anyone heard of that movie, Truman Show? No? Seems like nobody has ever. Look it up, Truman Show. I don't know if you don't know, if you haven't watched that movie, then it's really hard to. But the point is, Truman lives in a world, artificial world. He doesn't know that he lives in an artificial world, but um, everything everything in his world is a TV set, right? His friends, his family, everyone around him is an actor. Everyone around him, everything is so basically a make-believe world, and Truman is the only one who doesn't know that. So one day he set off to I don't know, I don't remember exactly, but he set off for whatever reason. He set off in a boat in the sea. Uh, and usually, real world, if you set off in the sea, uh, and unless, since you're on a small boat, unless you get shipwrecked or in a storm, or you will sail around the world and come back to the point of origin. You will come back to where you started from. But it's not real world. It's a TV set. So he went. He started rowing the boat, and a couple of days he was able to sail on. But then he reached the end of the world, which is just the TV set, end of the TV set. So that was a huge TV set. The reason I'm talking about this is, there's a theory in uh, uh, theory in cosmology that the universe is some uh, contraption of a giant computer system. So, and it also, came up also in quantum physics as well. So, through the telescope, they watch the night sky universe, and it's a huge, vast, space, right? And then some of the reports, papers say that the sector of the universe that wasn't visible, or I mean, that wasn't, there was no galaxy, no nothing in that sector. Suddenly, when observed one day, suddenly appears full of celestial bodies, like galaxies and stars. Obviously, this didn't happen just once. Must have happened. They observed this phenomenon several times, obviously, a number of times. So they wrote a paper about that, and so it could be a computer generation. There's a giant computer, God's computer. That's so when you're not interested in it, when you are not paying attention to it, it doesn't exist. But uh, when you pay attention to it, then it starts to exist, right? I'm digressing a little, but what I'm saying is, on this spreadsheet, I can, how big is the spreadsheet, you know? I can, you know, if I scroll all the way to the right, you see all these columns. But they were actually, do you think they were always there? No, they were not there. Actually, they don't have to, uh, Excel doesn't have to have all that, you know, area uh, if I don't use it. But if I need that space, the more I need that space, so I will expand to the right and to the, you know, to the bottom. The more I go down, the more rows are generated. The more I go to the right, the more columns are generated. So what does that mean? Um, I mean, that's possible on a computer. I mean, you know, the computer doesn't have to have, uh, there is no information to contain so far, so it doesn't have to exist. But as I need more space to put, you know, data there, then it needs more space, so it generates that space. So on a computer screen, I can do, but in reality, you know, if you try to put it on a piece of paper, there's a limitation. If you want to show it on the blackboard, right, on a chalkboard, I'm talking about a chalkboard, not this blackboard, it's inherently limited. It's constrained. So, for example, um, if the distance to the nearest galaxy is 1 trillion miles, and if this is 10 miles, how would you express 1 trillion miles? That's gonna, unless you have an infinitely large paper or infinitely large chalkboard, there's no way to express it. But then if it is, that's because you're only thinking in terms of normal scale. But there is something called logarithmic scale. And what is logarithmic scale? On a logarithmic scale, right, the distance is simply expressed by exponent. So for example, 2, this is 1, right? This is 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. So you might think, okay, so this must be 20 miles, is 2. And that must be 60 miles. That must be 90 miles. So it's 12. That must be 12 miles. I mean, 120 miles, I'm sorry. 120 miles, 60 miles. No, that's normal scale. That's normally you would think that way. If you're not a, you know, a very mathematical person and have very little training in math, that's the limit of your thinking. That's the limitation, right, that you have in your intellectual ability. But if you know what logarithmic scale is, logarithmic scale means this is 2, but then 2 means what? 2 is 10 squared, so that's 100, right? That's 100 miles. 3 is 1,000 miles. 10 to the third power cubic, right? 10 to the sixth, that's 1 million miles. 10 to the ninth, 1 billion miles. You see what? And 10 to the 12th, 1 trillion miles. You get the idea? On a logarithmic scale, right? This is how convenient it is. A large scale, large number, extremely large number can be condensed, right, into, so in other words, between 1 and 2, it's not, 2 times is 10 times. Between 1 and 3 is not, you know, uh, you know, uh, 3 times, but it's, 100 times between 1 and 3, no? Right? Does that make sense? Everyone has fallen asleep, or everyone has, what happened to everybody? Everyone is gone. Does that ring any bell? I'm again speaking to the hollow. Hannah, your microphone is on, so you understand what I'm talking about? Do you understand? Hannah, are you there? Hannah's gone. Christopher, are you there? Marisol, are you there? Oh, Christopher, so do you understand what I'm saying? Marisol, Christopher and Marisol, you understand what I'm talking about? You understand the concept of logarithmic scale?
Yes.
Okay, thank you, Christopher. Why does it take so long? Why does it take such a long time? Huh? Maricel, did you hear me? Do you understand the concept of logarithmic scale? Maricel, are you there? I don't know how much more I cannot just get bogged down with this. So the video was there, and this video will be posted today, and this session recording, and the past videos are all on YouTube. Okay, so you have to study, right? No matter how much, this is like third time repeating this, and no matter, because through the videos, it was through the lecture, it was already discussed. If you still say I'm confused, then I've done my part. I've done my share. The rest is up to you. It's your responsibility to make yourself understand, right? It's your responsibility to make yourself comprehend. That part is your effort. That's your responsibility. That's called studying. As I said, I quoted once, Winston Churchill's saying, blood, toil, sweat, and tears. Maybe you don't have to bleed, but you must do the toil, right? That part. Toil that requires sweat and tears. Okay? Mohammed, do you understand? Mohammed, are you there? I think Mohammed is lost. Jimena, do you understand?
Yeah, I understand.
Okay, thank you. I'm glad at least, two people understand. Hannah, we lost you for a while, but Mohammed, you raised your hand. Why, delayed response? Mohammed, do you understand? Do you understand
Yes, I do understand. My
the
mic is getting trouble. I don't know why. It's saying that.
okay, all right. At least you could have, typed into the chat box,
No,
Um,
the thing is, I
Hannah,
was speaking the whole time. It wasn't letting me talk. That's why.
yeah, you know what? That can happen because, when your computer is using up the resources. In other words, your computer needs, RAM, and RAM is, basically, processing holding, RAM is like a short-term memory. Usually it is the RAM. And if your computer has, your computer may have, 8 gigabytes or 16 gigabytes of RAM. 16 is already a very, very, a double, the most of, regular. And if your computer's resources are all taken up, something's gotta give, right? That happens. If you have, check if your computer has too many windows open, not too many apps running all at the same time. Then it could, resources are being, your resources are short. You're falling short of the RAM or something, or CPU. That can happen. Hannah, we lost you for a while. Hannah, did you hear my explanation about logarithmic scale?
Yeah, I understand. Yeah.
Okay, good, good. Okay. All righty. You can quickly check, everyone has, their own, in their own computer, you have task manager, right? You have the task manager. And usually this is showing the usage of my CPU, and it's like on average it's about 50% of its full capacity, so I'm good. Memory, short. I have 8 gigabytes of RAM. Usually it's expendable. I don't know, depending on your computer. If I can expand it, I would expand it to 16 gigabytes, if possible. Memory chips are very expensive these days. They were not that expensive a couple of years ago. Usually that's it. That's it. As long as they have some free space, plenty of free space, and another thing. Oh, so that's already 1 hour 30 minutes so far. So that's log, right? That's log, right? The reason for using logarithmic scale. But then here, so as I said, there are 3 commonly used logs, log bases, base 10, base 2, and base E. And it's not difficult to understand, base 2. It's basically, powers of 2, 4 is 2 squared, so it's, log 2, base 2 log of 4 is 2 because it's 2 squared. Base 2 log of 8 is 3. Base 2 log of 16 is, 4. It's basically, and base 10 log is commonly called common log, common because it's the most commonly used logarithm. Base 2 log is called, binary log, binary. And base E log is called natural log. Or, it's the same thing as log using Euler's number E as the base is called natural log. So then, what is, now this is really handful. Why? Because you don't understand what Euler's number is, in the first place. But I've been telling you, this is not the main lecture. The main lecture was already, delivered last week, right? In the in Collaborate, in the through the pre-recorded video. So we had a lot of, 3 videos about Euler's number. So recapturing it here is really, really difficult, especially within the, but, let me try the best. So let's think about it. So you all understand. what is this? What is this part? 1 plus APR over M raised to T. But forget about forget about T. You know, and forget about P, because later you can just multiply P, right? So focus on this part only. 1 plus 1 over M. You might wonder, what about APR? Forget about APR. You can always plug it back in there. You can always plug it back in there, right? So what is interesting is 1 plus 1 over M raised to M. I mean, T times M, that's N, right? But eventually, forget about T either, because we've done that, because APY, effective interest rate, remember, effective interest rate or star or APY what's the formula for that? Formula is 1 plus APR over M raised to M. Okay. So that is, basically the term that is used for finding APY. And of course, ignore APR. I mean, or assume APR is 1. Okay. Assume APR is 1. That means 100% if it is 1, right? If you assume APR is 1, which is 100%, right? Because we can always replace this with actual APR later. And then, so think about it. Next question is, okay, in the limit, right? So that means, suppose, what if that M goes to infinity? Okay, that's the symbol for infinity. Everybody knows this, right? Infinity, right? And if you think infinity is a car model, right? Infinity is a car model. I'm just, I will just have to say, I'm speechless, and everybody would know what, infinity is, of course, infinitely large number, I mean, in terms of numbers, right? There's no end. But if you don't know what the symbol for infinity, that's the symbol for infinity. I mean, this is something. When I was a kid, I mean, I belong to old school, because I'm. I graduated from college in '83, so that gives you an idea, how old I am. '83. I got my bachelor's, So then, when I went to that was in 1970s. I went to a high school and middle school in the 70s, and in those days we learned all this. The math class, sixth grade math. No, maybe not sixth, but at least seventh, eighth grade math. In these symbols, math was, basically, from the middle school. It's algebra. So you know all these symbols, because but these days, especially in public schools in the U.S., public schools, nobody teaches real math. They are just doing I don't know what they do, but they don't raise a generation that can do logical reasoning and analytical reasoning. The thing is, in you can't do logical reasoning and analytical reasoning when you are 13, 14, 15, 16. During those days, during those years, you have to be taught, like even if it is even if it has to be through memorization, you have to be taught in the old way, like a military boot camp. Because there's a reason for military boot camp, because in the military boot camp, um, you don't have any independent, you don't have your own time. You have to follow the schedule, and you have to do, you have to carry out the order exactly as instructed. But there is efficiency there, and you may not, you can, you don't need to do any soul searching for that order. Only later, when you are more mature, when you are, when you get promoted, like from the lowest rank, private, to, let's say, you got promoted to sergeant, or then you understand the rationale behind it, why that order was given, why that it had to be carried out in that manner. And it's just like that during middle school and high school. If you can do rational thinking, that's fine, that's good, wonderful. If you can do analytical reasoning, that's wonderful. If you can do logical reasoning, that's wonderful. I'm not telling you not to do it. But if you're capable of, who wouldn't want you to? The thing is, most of the teenagers are not capable of that. So then what? You need to learn to stick to certain, you need to learn to uh, stick to a regimented method. You have to do it according to the regimented methodology, right? There's no other, and then you get better at it through that regiment. Regiment is what? It's a training. It's a drill. You keep doing that in that uh, regimented fashion. You practice that, and you get better and better. And until you get better, until you master it, right? You just need to keep following the regiment. And when you have, after you have mastered it, then when your intellect has more matured or fully developed, then you realize, oh, reflecting back on those days, why did I do it? Why was it done this way? Oh, it was because of this and that. Or everything falls into place. Everything falls into the place. And you can connect the dots by then. But when you were like 15, 16, 17, because you're not capable of logical reasoning and analytical reasoning, you need to follow the regimented method. And that without that phase, later you cannot be a creative, you cannot produce anything. They say, think out of the box. You need to do the creative thinking, blah, blah, blah. Easy to say. How do you know what the box looks like when you don't know? You have to be first, inside the box. You should know how to draw the box. You should know what the box looks like to be able to think outside the box. And only when you can draw the box well, then you can create something outside the box. They say be creative, and then all you can think about is just some abstract art. You can't, and then that's not thinking outside the box. I mean, thinking outside the box, just painting. What problem does it solve? If you think outside the box and all you can think about is some painting, right? Painting on abstract. What problem can you solve? Right? Problem solving through creative, thinking needs to know what is the methodology first, and then if you have mastered the methodology, then you can think outside the methodology, because or that means how to tweak the methodology, right? How to tweak the framework, but you need to know the framework to be able to tweak the framework. So that was how it was in back in the 70s, 60s, and prior to that. But now they don't do it anymore. So the students don't know what this symbol is. They are in college. They don't know. This is the first time they ever saw. And they don't know what this limit means. First time they ever saw. Well, what this means is you read it like this: in the limiting case where m approaches infinity. And they can't translate this. What does that mean? Most college students can't translate this. What it means is in the extreme case where the compounding frequency approaches maturity, that means approaches infinity. So you remember m was what? Compounding frequency, and so far all you knew was it was 1, 2, 4, 12. What else? 12, 365, 52 there was also, right? But then, is that it? What if the compounding frequency is in infinity? Meaning, what does that mean? You are, what are we breaking? What are we breaking? Aren't we breaking 1 year into 2 pieces or 2 segments, 4 segments, 12 segments, 365 segments? Isn't that right? We are segmenting 1 year. In other words, we're breaking up time into smaller pieces. You understand? Does everyone understand what I'm talking about? Nobody's saying anything again.
Yes.
Christopher. Yeah. Oh, Jimena. Okay, good. Thank you, Jimena. Hannah, do you understand what I'm talking about?
Yeah.
Okay, good. Thank you for responding. Yeah, we're trying to break up time, right, into smaller units. 1 year, we're trying to break up 1 year into smaller units, right? Because that's what this was all about, right? Breaking up into 2 segments, which are 6 months each, quarters, months, days. So if we extend that to infinity? If we are breaking up 1 year by infinity, right? So think about it. What is this going to be like? What's this number going to be like? You're dividing 1 by infinitely large number. What's it going to be like? Hmm? Nobody has any idea? Don't talk to me about creative thinking, blah, blah, blah. That's all bullshit. That's all rubbish. You can't even, this doesn't even require high intellect. It's just logical. You divide 1 or any number, you divide 1 year or 1 minute or 1 hour, any number by infinitely large number. What's it going to be? It's only logical. No one?
0.
Yeah. Who said 0? Who said 0?
Jimena.
Jimena. Yeah, Jimena. That's not exactly the correct answer, but you get extra point. Yes, it will be. It's not exactly 0, but it will approach 0. It will approach 0. It will be, in other words, it will be infinitesimal number. What does that mean? Infinitely small number, right? And of course, saying 0 is very logical. And at least Jimena can think logically. What about the other people? You lack logical thinking? I'm not asking for, this is a very straightforward logic. You divide something, it doesn't have to be 1. Even a large number, very large number. You can divide very large number, but you divide it by infinitely large number. Nothing is significant when you are compared to infinitely large number. Isn't it right? Who is the tallest person in the world? I mean, I don't know who's the tallest person, but Charles Barkley is very tall, basketball player. Well, Michael Jordan, how tall is he? Charles Barkley and who? Oh, I think Yao Ming is taller. But let's say, how tall is he? 7 feet something, Yao Ming, or 7. Let's say there's a very tall basketball player, 8 feet tall, 8 feet. I'm barely 6 feet. I'm 5'11", not 6. But even if I were 6, someone 8 feet tall, 2 feet taller than me, and that's a huge, that would be the tallest person, in the world, 8 feet. Don't you think? But even if you're 8 feet tall, compared to infinity, you're nothing. You understand? So divide any number by infinite large number. The result is close to 0. It will be an infinitesimal number. In other words, infinitely small number. Infinitely small number. Right? Make sense?
Yeah.
Yeah, almost. That means almost equal to, right? Not equal to, but almost close to, right? Equal to 0. So what's going to be this number? This number will be something slightly greater than 1. Isn't it right? This number will be something 1 plus 0.000000, infinitely 0. 0.00000001, right? Infinitely 0. Okay. All right. But then think about it. Was this term just like this? Was this term just like this? No, it wasn't. Why? Because there was an exponent. right? That m was there. Now let's think about it. M is going to infinity, so that means this number is raised to infinity. And our question is, what is it going to be? What's it going to be? And think about it. If this is 1, right? If this number in the parenthesis is just 1, right? The problem is easy, right? The solution is very easy. If this number is 1 raised to infinity is what? If you raise 1 to infinity, what's it going to be? Anyone? This is also logical thinking. And something even an 8th grader can answer. Well, how come you are college students and you can't answer that? Shame on you. Who can answer this? Mohammed? Are you there, Mohammed? Mohammed, are you sleeping? Huh? Maricel, are you there, Maricel? Nobody's answering. Oh yeah, Jimena, thank you. 1. Yes, you got another 0.25 for that. Thank you. Yeah. Oh, come on. Come on, guys. Come on, people. This is just logic, nothing but logic. You raise 1 to infinity, it will still be 1 because it's 1 times 1 times 1 times 1 times 1 times infinitely times 1. So what's it going to be? Still 1, right? If it is 2, it's going to be a huge number because it will be an infinitely large number. Anything greater than 1, the thing is, anything greater than 1, you raise anything greater than 1 to infinity, what's it going to be like? Oh, you can't, it's going to be greater than 1. Of course. Why? Because it's not 1. It's still, even number like this number is what? The number in the parenthesis is like 1.000000000, infinitely 0 and 1. So this is a number slightly greater than 1. So don't you think this is a very interesting question? You are raising something slightly greater than 1 to infinity. Slightly greater than 1 to infinity. What's it going to be? Will it be a huge number, infinitely large number? No, it's not going to be an infinitely large number. It's got a limitation. It's got a limit. It's got a limit. And so that's what it means. If you raise 1 plus 1 over infinity to infinity, and this number is just slightly greater than 1, insignificantly greater than 1, right? Infinitesimally greater than 1, you raise it to infinity, right? Then that number is called Euler's number, and that number is it's an irrational number. It's not a fixed number. It keeps on going. I just used 3 digits, but it goes on forever. 2.718, and it keeps on going, right? Something. So e raised to 1 is just itself. It's 2.718, 718, 18, something. It keeps on going like that. Okay. So if you use an interesting thing is, why is this number so important? And you can tell why from our example, right? Remember here, okay, you can already tell when m is 365, actually it's getting closer to 1.187 in gross terms. You subtract 1 from that, it will be, in other words, you subtract 1 from this. This is, the result of 1 plus something. So if you subtract 1, it's going to be 1.718. You understand? Subtract 1 from it. Because you understand what I'm talking about? This is the result of 1 plus, right? 1 plus this raised, the whole thing raised to infinity. So this is the gross, result, gross result, right? Just to get the net return, you subtract 1 from it, so it's going to be 1.7. Now, the reason that this is important is because Euler's number is important, is because it is used as the base of log for any number. It can be used. In other words, what did I say? We can take base 10 log, in other words, common log of theoretically any number. We can take common log of base 10 log of 17.237 or something like that. Theoretically, that's possible, but we can't calculate it mentally, right? We can't easily visualize. Oh, with the computer, with the calculator, we can calculate it, but it's impossible for human brain to quickly visualize what this might be, as opposed to something like log, base 10 log of 1 billion, right? Base 10 log of 1 billion we can easily process because we know it is, 1 billion is, 10 to the 9th. So we can tell it is 9, right? But this, we cannot easily do that. So, but anyway, it's going to be the computer that's going to calculate it. But with base n, with base e, right? You can take log of any number, right? You can take log of any number. It can be also written as, it is also written as natural log of any number x. Where was it? I was writing it here. You can take natural log of any number x. And why? Because now think about it. If you take, you might wonder, okay, so there's common log, there's binary log, and natural log, and common log uses 10 as the base. Natural binary log uses 2 as the base. But then can we use 1 as the base? No. That's the thing. It looks like, if you use 1 as the base, then it would be no. But think about it. Nothing is the power of 1, right? 1 cannot be raised to a power to get to any number. 1 raised to anything is always 1. Isn't that right? Isn't that right? 1 raised to anything is always 1, so 1 cannot be used as the base. But what if it is a number that is slightly greater than 1? A number that is slightly greater than 1? Yeah, it can serve as the base for any number. Of course, that the power. I mean, it may not be exactly, neat exponent like, uh, in integers, like, 1, 2, 3, 4, 5. It won't be, in integers, but still, it can serve as the base of log for any number. So that is why, and so we're going to be, and understanding natural log, right? Understanding natural log is a key to solving this equation for n, right? You understand? It will be key to solving this equation for n, right? I should. The point is, what is n? Okay, and the properties of the log that can, which property? Um, Basically, the property of, being able to bring down this exponent, uh, like almost as if making it a coefficient, right? That will be a very, useful and critical feature that comes with the log. All right, so I think we are out of time. I thought I would. I just want to remind you, you got this email. You must have got this email. I extended homework 2. Okay, did you all check this out?
Yeah.
Yeah, thank you. Was it Jimena?
Yeah.
Okay, almost looks like you are the only one in the class now. So you got this email, okay? So I gave you extensions, so please, be more. You have more time, so be more thorough with your homework. And if you have already submitted homework 1 and got my got the graded homework back, and read my comments. Someone who did well, there was hardly any comments, so you can just keep doing like that. But if you got it back with a lot of comments, you should pay attention to those comments. Okay, it takes me a lot of time and effort to write those comments. It takes up my entire weekend, and it's very stressful to write it. All righty, so that's it for today. I'm gonna